every Monday, providing foundational knowledge in different impact areas and giving you tools and takeaways that you can apply to your everyday work. I'm Mark Kalin, president of Kalin Associates, a Boston-based firm that provides architectural specification writing services for architects, public agencies, and building product manufacturers. I'm delighted to be joined today by Mikhail Davis, Director of Technical Sustainability at Interface, a global commercial flooring company with a climate take-back mission. Chris Magwood, a designer, builder, researcher, and educator, and the director of the Endeavour Centre in Ontario. And Jesce Walz, an architectural designer at Perkins and Will, who's engaged with the firm's EC3 work, as well as other sustainability initiatives. I would like to take a moment to thank our sponsors for this series: Arc Woods and Services, Goody Clancy, Huber Engineered Woods, Kingspan, Select Building Products, and ThoughtForms. We're grateful for your support. And thanks also to our partner, the Associated General Contractors of Massachusetts. And I'd also like to recognize that this program series is supported by Carbon Leadership Forum and its local knowledge community, CLF Boston, which we invite you to join if you're interested. Before we dive in, a couple of notes about this program. One learning unit, HSW, is available for those who are eligible. We will share a link to a Google form in the chat box. If you want continuing education credits, please add your name, email address, and AI number there. If you're not an AI member but want a certificate, please enter your name and email address. We are recording this session, and it will be posted to the BSA website, architects.org, later this week for you to access. We ask that you share any questions using the Q&A function. While we might not be able to address them all today, we will use them to inform future programming, including the 11 other sessions in this series. And with that, let's begin. Over to you, Mikhail.
Thank you, Mark. All right. I am going to share. Is everyone seeing my screen?
Yes.
Thank you. Okay, great. So yeah, I work for Interface. We make flooring, but we also are trying to make the community of business actually a solution to environmental problems rather than a cause of them, as is traditional. And that has been our mission for the last 25 years. So one of the tools we discovered along the way is life cycle assessment. And we wanted to measure how are we doing on this mission. So we started very early on, over 20 years ago, working using life cycle assessment internally to measure when we change something, be it a process or an ingredient, did it make us more sustainable? Because occasionally there were bad surprises where something that seemed more sustainable actually resulted in a higher environmental footprint. So then around about 2008, they had already been around in Europe, we got into this idea that it really would make a difference if we started publishing our LCA and using this new idea of the Environmental Product Declaration to publish. So we were the first company in North America to publish an EPD for a product, any type of product. They exist beyond the building industry, used broadly in electronics and some other categories. But really, we wanted to make this a thing. But the thing that really tipped it over, and this is, again, I'm going to give you 3 reasons why EPDs are important and why we should care about them. And then a brief journey down the wormhole into how you make an EPD, not too in-depth, because that gets pretty nerdy pretty quickly. So EPDs, number 1 reason, and this was the thing, we did an EPD back in 2009. Nobody really cared. No one knew what it was. It wasn't until they put them into LEED. So reason number 1, even if you don't know what an EPD is, you can get a LEED point for it. Collect those EPDs. Used to be 20 products. You had to get 20 products that had EPDs to get 1 point. They've actually lowered it down to 10. This is like the easiest point to get in LEED. So the first number reason, you can get a really easy LEED point. So collect those EPDs. That's this, if we look at our building product disclosure and optimization credits. So I was the chair of the MR tag for LEED after V4 launch. So we were the fix-it tag. to try to fix all the credits that didn't quite work. So version 4.1, a lot smoother, even easier on some of these. We want to make sure a credit that no one actually uses doesn't change the world. So we had to lower the bar on some of them. So this bar right here, of course, above that is your transparency credits. Below that is your optimization credits. Environmental product declaration. This is the one where you just have to collect the documents. You have to know, and Chris will talk a little bit about this, whether it's for the whole category, whether it's product specific. Is it for, you know, ceiling tile in general, or is it for Armstrong brand ceiling tile? The latter being the product specific. Now, the interesting thing was, if you look at the progression of LEED, environmental product declaration really in most ways replaces a lot of the old materials credits, which of course were then packaged all into one single point. This used to be like 4 in, you know, the old LEED 2009 version. It is now 1 credit, and it's really more about how are the resources extracted. It's not trying to be, which it used to be, a proxy for environmental footprint. We're now using LCA as our environmental footprint metric in the EPDs. And recycled content, this is more about where do the materials come from, where are they going, sustainable wood and fiber. Environmental product declaration is really where we should be looking for this question, you know, is this a low or high environmental impact product? Now, the problem was that in LEED 4.0, we made the second EPD credit, the one where it shows that you have a better EPD, that you've actually decreased the footprint, and you can show that in LCA. We made it impossible. The way it was written, no one could get the point. You had to get 50% of your material spend had to meet this criteria, and very few people even had the documentation, let alone 50% of all the materials on your project. 4.1, you only have to find 10 products that can meet this criteria. You can actually do this question now. So this is the big news in terms of LEED, is that we can now be asking for optimized EPDs. We can now be getting this point and actually driving all these manufacturers who really stepped up and created the EPDs to say, yeah, now you have to use them to lower the footprint of your product, and show us that, and we'll give you this other point. Quick reminder, if this credit doesn't exist anymore, don't ask people for CSR reports. This was a wonderful idea that we actually pulled in LEED 4.1. So don't ask people for CSR reports, because that really never worked. Sorry, I spent too long wrangling that credit as the chair of the tag. Again, the big news in LEED, we're also going to start to have more of these sort of project-wide low carbon credits. So there's now a pilot credit for low carbon procurement. There will be an interiors version of that launching soon. But all this great work we're doing with Tally and EC3 and other tools, we need to be able to get LEED credits for. And LEED is a little behind on this embodied carbon thing and scrambling to catch up. Reason number 2, I said I was going to give you 3 reasons. This is the one, and this is really looking at it from a manufacturing perspective. If you just produce the EPD to check the box for your customer and say, oh, well, we got you your LEED point, go away, you are missing the biggest return on investment that you could have, which is that doing LCA and doing the process of publishing your EPD, which creates some accountability if someone ever reads your EPD, which Chris will get into how and why not to do that. But you should, if you do this right, this could be a huge source of value, because you know you have to do something about carbon now. You know you have to do something about the environment. Every company does. Where should you spend your money? Where are your hotspots of impact? What's the elephant in the room for your category? If you make a car and you don't address fuel economy, you know, but you make it out of recycled materials, you're really missing the hotspot. And for the most part, if you look at a product like ours, we make a thing. So if you're talking about things versus machines, is a really useful rule of thumb in LCA. A thing doesn't particularly use energy during use. So we make flooring, it sits there. You have to vacuum it. You have to, you know, sweep it. A little bit of energy resources gets used on that. Not a lot, not compared to a car, where there's a huge amount, or an HVAC system, huge amount of resources are going to happen in this use phase. So if you had to guess, and you know, what is the big hotspot for most things, you know, like a carpet tile or a floor tile or ceiling tile, overwhelmingly in the raw material extraction and processing. These numbers are going to vary slightly, but these are typically the number one answer I get when asked that. People think about transportation because it's really easy to imagine. 3%. And that's all the transportation through all the life cycle stages. Everything from trucking rock from the mine to the place where they grind it into rock dust, or, you know, trucking, you know, piping gas from where they extract it, you know, from the fracking well. All of that trucking, all of it adds up to 3%. So again, this is why you no longer have a locally sourced materials credit in LEED. It's not a good proxy for environmental impact from most products, unless you put it on a plane or something dumb like that. Now for a machine, you're gonna have to look at this use and maintenance phase, which is 9% for this carpet tile, which is what we have the data up for. That's gonna be the big bar for a machine like an HVAC system or a car. So reason number 3, you know, so reason number 2, we're really talking about getting your return on investment. Focus your attention on where in the supply chain, where in your footprint you actually have the biggest impact. It means changing out, for most things, what you make your product out of. If you can't address the raw material sources and fundamentally change those, you're probably going to miss most of your impact. This is the obvious one, and I'm going to frame it a little differently. This is the EPD is where you find a product's impact on climate change. And the trick here is that we will get into, and this is what I like to remind people at the top, we will get into some really dry stuff, especially when we get into the guts of LCA. And this is what needs to get you through emotionally, is that this really matters. This is where we find out what impact do we have or not have on climate change. Because climate change is not just this abstract, oh, well, we're gonna have some sea level rise and we're gonna have some hotter weather. It turns into, when you really run this experiment through, the biggest challenge to public health in the 21st century. And CDC, World Health Organization, you know, Harvard School of Public Health, whoever you ask, you can Google it, #1 threat to public health in the 21st century, in spite of the global pandemic we're in, it is still climate change. Because it makes all of these other things worse. It affects so many things, it affects everyone. And then, of course, the other really important thing to consider is it doesn't affect everyone equally. It affects the most vulnerable people who can least afford to be disrupted by extreme weather or new disease vectors or you know, failure of agriculture. You know, it does not affect people equally. And so long as we do not address, for instance, where our materials come from, chances are they all come from communities that look like this, places where the people are most vulnerable and can least afford to move, you know, so we got to live next to the oil refinery. And so even as we select and we think about this very, you know, important topic of healthy materials, most of the red list free materials or whatever other screen we're using also come through communities like this. So just because your petrochemical doesn't end up toxic doesn't mean it didn't come from a refinery. So red list free, but not a healthy material. So fundamentally, the shift that I would like us to take on, and this is very much what our mission is about changing our thinking on climate change. We know we can change the climate. What if we did it on purpose? What if we actually tried to create and design, as designers, taking on the biggest design challenge of all, a climate we actually want? Rather than, you know, a lot of the narrative is about making things less worse or making our seawalls higher, and there's gonna be some mitigation, there's gonna be some stuff we have to do, but the goal is not to have a climate that doesn't suck quite as bad. We need to have a goal that is actually worthwhile and that we can actually design toward something, a future that inspires us. So with that lofty goal and those important issues in mind, let's dig into some of the details. Because what these details start us on, if we look at LCA, something as a little bit dry as LCA data, start to get this disclosure in our EPDs, we can actually get on a path to designing the world we want. We can get to, let's eliminate, we know what those negative impacts are. We've got the EPDs and other tools. We can reduce the negative impact, but then we can really start to, in a grounded way, work on designing spaces and buildings that have a positive impact on the world. where we are actually storing carbon in our building. We are purifying water. We are producing more energy than we're consuming. We're creating habitat in our buildings. But it has to start with transparency and a real assessment of where we are now, which is one of the key things that LCA enables. So EPD, we're going to dig into, these are wonderful slides that I borrowed from Terry McGusky, who presented this at the American Council on Life Cycle Assessment Conference. It's a truly deep dive into life cycle assessment, which is now taught just about every university, come a long way in the last 25 years. So you'll see in lead documentation and other places, it has to be a product-specific type 3 environmental declaration. An EPD is by definition a type 3 environmental declaration. You don't have to ask for your EPD to be type 3. An EPD is a type 3. And type 3 just means it's not a green claim. It's not like 30% environmental, it's not like certified to meet this standard. Those are type 1 and type 2 declarations. A type 3 just means we're going to give you all the data in a standardized format. It doesn't actually make any claims. It's not more environmental because it has environmental product declaration. It just is fully disclosed data according to life cycle assessment. That's all type 3 means. So steps to create an EPD, and there is a much great deeper dive. If you are working with manufacturers closely or work for a manufacturer, I can give you the full detail on this, but essentially I want to define the key terms so you know when you ask manufacturers for EPDs, which as designers is one of the key things we really need you to do right now. If people don't have them and they're not on this journey, they need to start tackling LCA, understanding their hotspots, transforming their supply chain. But they can't do that if they don't actually have the data. And you can't assess their product if they don't have an EPD. So keywords here. So we need a PCR, we need some LCA, we need an EPD. Yeah, so these cool, this is as hip as the ACLCA gets. These cool people will, some of them look like they're straight out of Japanese anime. Let's publish an EPD. First, we need an LCA. Let's make sure the LCA follows a PCR. Yeah, the EPD is based on an LCA which follows a PCR. It's still not cool. So 3 key acronyms: PCR, LCA, EPD. How do they relate to each other? PCR is a product category rule. This is what you need to, so an LCA, which we'll talk about, is really just an input out. It's a modeling exercise for what is the full environmental impact according to all of these standards of producing this product. The product category rule is a key set of rules that goes with that. It is specific to the product category, so be it flooring or plumbing fixtures or whatever. You need to have a set of rules that sets the boundaries and assumptions for that modeling exercise. So we say, okay, so we're installing flooring. Do we have to include the impact of producing the glue that we have to glue it down with? If one manufacturer says yes and says, oh, we included the glue, so your footprint is a little higher, and the other one says no, oh, we didn't include the glue, there's no consistent rule. Those data are not going to be comparable because this guy used one set of rules, he included the glue, and this guy didn't. So the PCR, for flooring, for instance, will say, yeah, you got to include the glue, and everyone does it. And suddenly we're closer to having actually comparable data done for, different brands of the same product. But to the degree to which those rules haven't been created for a product, you have to go back and get a PCR created for that category. So the LCA, every LCA needs to have goals and scope and needs to have an inventory analysis. Inventory is literally the inventory of materials going in and out of you sometimes see the expression LCI, life cycle inventory. That's the material flows in and out of the supply chain. And then impact assessment is where we translate those material flows into impacts, like impacts on water quality or on climate change. So yeah, this is life cycle. You're going to go through all your life cycle stages. You're going to start with raw material acquisition. You'll sometimes hear that referred to as the cradle where the earliest stages of the product are born. And then the recycle or waste management is a grave. That's cradle to grave. Cradle to gate would end midway through this, where we end at manufacturing. That's like the manufacturing plant gate for the final product production. So cradle to gate is the first two. Cradle to grave is all of it. But again, what we're looking for is what went in, what came out. So the output. And so you're modeling this, and to the degree to which you don't have, if you're manufacturing your plant, you should have actual data for that. That's what should go into this model. A lot of times you will not have all the data. You certainly won't necessarily have the data for exactly how people vacuumed your flooring. So you have to put in modeled data. And that's where tools like Gabby and SEMA Pro, these other things, they put in very, the better tools have really good data sets to put in and say, well, here's what an average North American vacuum uses. And then when the product category rules, it will define what is the maintenance frequency for that product. So we say, okay, so using this data for what the emissions from powering a vacuum are, I'm going to say that it's once a day, and then we're going to multiply that, and that's your impact for maintenance. So you can see you have to layer in the data set from, for instance, we say, okay, well, we use this kind of plastic. Here's a data set from the production of this kind of plastic in your region. Ideally, it would be your plastic supplier, but a lot of people, and this is where we as manufacturers have to do the same work of asking for LCA of our suppliers that designers need to do, which is to say, I need your actual data. And we've done this with our suppliers, and it makes a big difference where we suddenly realize where their hotspots are, which become our hotspots. Okay, so your recycling machine is actually on a coal-fired power grid. What can we do about that?
Mikhail, 2 minutes.
Thank you. I'm running behind as usual. Anyway, so PCR informs our LCA. Then EPD is really the format in which it gets published. You can either, as a manufacturer, do this yourself, or you hire an outside consultant to do your LCA. You always need a program operator to publish your this, and they're going to make sure that you've had the LCA verified, ideally by an outside party, but you can also have it done by an LCA person internally. Obviously better if it's an outside party. So hopefully these cool cats make a little more sense to you now. The PCR is necessary to link an LCA to make it comparable. The EPD is where it all gets published in a standardized format. And all of this enables us to actually start to look at building products and say, okay, what has a higher footprint? This is a great study that Carbon Leadership Forum did. It was across averaging material footprints across 4 tenant improvement projects. And you can look and see like, oh, wow, what jumps out at us here in terms of carbon footprint? Okay, carpet. I'm going to pay attention to that. Then we actually can go and look at EPDs for carpet and say, all right, so this could be high, so I need to make sure to really pay attention within EPDs, and this is the kind of thing that hopefully EC3 can help you with, and you won't have to read this 20 EPDs and say, wow, some products in this category are really quite low and some are quite high. Let's pay attention in this category. So EC3 is what, if you are in the 9 product categories that are open in EC3, this can help you with that final stage of product selection so that you don't have to read EPDs. Because ultimately, as a designer, that's the thing you want to not have to do, is to read EPD. Chris is going to give you tips for if you do decide to be that brave person that does. But all of these sponsors have realized that, wow, we really want to not read EPDs. And so we're getting lots of good sponsorship and partners for the EC3 tool, because it enables that process to be automated, and all you get to see, as Stacy pointed out last seminar, is what's better than what. For the product I'm specifying, where are my low, medium, and high carbon options? So buildingtransparency.org, if you haven't played with the tool, do. This is another one I'll quickly show you. This is the qualitative version. If you really are not going to tangle with EPDs, you still can reduce in low embodied carbon, materialspalette.org. Again, there's only certain product categories they've given guidance for, but some key ones. To where you know your general rules of thumb, spec this, not that kind of things. You don't know numbers, but you can at least get qualitative and get them going in the right direction to reduce embodied carbon. You want to really dig in, great book on this whole project of how do we get buildings to become a carbon sink rather than a carbon source. New Carbon Architecture by Bruce King. Finally, and this is just going to give you a little inside baseball for manufacturers since we love our green claims, relating traditional green claims to embodied carbon, made with recycled materials. That might matter for embodied carbon, but what really matters is if your recycled material is displacing a high footprint raw material, like a virgin metal, virgin plastic, cement. That's what it is. It's not about the percentage. It's about, okay, your 10% recycled content, but if that displaced the highest footprint virgin raw material in your product, that's important. So it's recycled content, but then we need to know a little bit more information on that. Renewable energy. If it's just for that final manufacturing stage, it needs to be a lot. Because if you remember from my earlier slide, the final manufacturing production, for us is now like 3% because we have a really efficient, factory. So 3% of your footprint, if we eliminated it completely, is still not that much. So you need to get, so if you're talking about manufacturing, energy use for final manufacturing, it needs to be a lot of renewable energy. One solar panel is not going to do it. So if you're looking for this as a proxy for reducing the embodied carbon of the product, it needs to be a lot. It needs to be 50 to 100% renewable energy. And finally, carbon neutral. People will throw around this claim. First of all, they need to be third-party certified claims, and they really should be for the whole. If you say, well, my factory is carbon neutral, that's that 3 to 15% again. So it's 3 to 15% carbon neutral if it's just your factory. What you really want is the whole life cycle. Looking at, here's my EPD number, and I went and bought at least the number of offsets that it said in my EPD for the whole cradle to grave. And again, if they make you pay for that and say, oh, well, there's a carbon neutral fee, that doesn't have the impact it should, because how this could function, carbon neutral, you're buying offsets. It's not the most exciting thing ever, but it could serve as a carbon tax. Basically, you tell someone selling you material, you have to pay for those offsets yourself until you figure out how to reduce your footprint. Government's not giving us a carbon tax, but you, as a designer, can start to drive us in that direction. Finally, and I'm going to leave this to Chris to really explain, made with bio-based materials. This used to be a really sort of kind of claim. If we tie it to embodied carbon in the right way, this could become a really exciting claim, but it needs to be accompanied by well-verified LCA data as to, okay, did my bio-based materials actually capture carbon, maybe even start to get us to some carbon negative products that are actually storing carbon. So I'm going to leave it there and pass it to Chris. Okay, thanks, Mikhail. That was great. You left me in a great spot, so I'm excited to take over. I think you have to stop sharing your screen though in order for me to share mine. I believe that I did. I did hit the button. We might have a little delay. Okay, there we go. Okay. And okay, is that coming through for everybody?
Thank you. Yes.
Terrific. Okay. So I have a set of slides, the first of which I'm going to go through, I think, fairly quickly, but to sort of give everybody a grounding on what information you'll find in an EPD. So like Mikhail said, an EPD is a way of reporting the results of a life cycle assessment. So the life cycle assessment does what it says. It looks at the entire life cycle of a product. But within the EPD, the various stages of the life cycle of that product are reported on separately so that you can kind of compare not only the total number for the whole product, but by phase. And so they're broken into categories. So the product stage, the cradle to gate, as Mikhail said, which are known as stage A1 to A3. So that's raw material supply, transport, and manufacturing. That's basically the material emissions. And that's that piece that Mikhail sort of pointed out as being quite large, especially the raw material supply portion. Then there's construction stage emissions, and this is known as A4 and A5. And this is what it takes to transport those materials to your job site and the emissions associated with actually building the building. So whether that's running diesel generators, running cranes, those sorts of operations, that's included in A4 and A5.
While the one thing I want to point out is that the product phase is relatively straightforward to assess in an LCA, because those manufacturers all along the phase, they have pretty good data. You can collect quite sound data on the raw material supply, the transport to the factory, and what goes on in the factory. When you get to A4 and A5, an LCA has to make a lot of assumptions. It has to, for transport, it has to assume, you know where the factory is, but you sort of have to generalize about what's the average distance that it might get shipped. Or if there's an installation process, they're going to assume that you're doing it with a certain kind of equipment, or that it takes a certain length of time to do it. So you'll have to, if you really want to do a good analysis for yourself, you want to understand what that LCA, what the assumptions were in A4 and A5, to get a sense of whether or not you will have similar impacts to what is being assumed here. There is the use stage emissions, and when we're looking at just products, so when you're comparing different products, the operational energy use isn't really part of that. So, in Mikhail's example, the carpet doesn't have an operational impact. You don't heat the building more or less because of the carpet. The carpet doesn't require any operational energy over its lifespan in the building. So when we're looking at products, we're excluding B6 category. But what we are looking at is B1 to B5. So that's use, maintenance, repair, replacement, and refurbishment. And so again, you do want to understand what the assumptions in that life cycle assessment are. Everything from how often maintenance happens and what kind of maintenance, what the repair cycle will be, how often the product needs to be replaced. All of those things, again, are going to be based on reasonable assumptions, but they will be assumptions. And so if you want to sort of understand what you're seeing in this EPD, you'll want to see in the guts of the EPD what those assumptions were. Same goes for end of life. So first of all, an expected lifespan will be attributed to the product. And then C1 through C4 sort of looks at what happens at the end of life. So what are the emissions associated with deconstruction or demolition of that building / material, the transport of that demolition material, waste processing, and disposal. And you'll see that this is starting to become a bit of a habit, but again, there are a whole bunch of assumptions built into that life cycle assessment. For instance, whether materials are going to go to landfill, whether they're going to be incinerated, whether the LCA is sort of attributing a portion to both of those means of disposal. So there's a lot to sort of know there too, if you want to be able to compare. And then finally, there are beyond the boundary impacts, and largely these are to do with impacts from recycling and reuse. So a material that is able to be recycled is, say, offsetting the need for more virgin material, so it'll sort of be given a credit at the end of the boundary system here. So I went through that just because it's really clear, it's really important that you understand as a practitioner what part of this scope you are trying to compare for your analysis. So if you're looking at an EPD, is it to understand your product level impacts? Is it to understand your use level impacts, your end of life impacts, all of them together? Do you want to be able to weigh them out separately? And you need to know that because you'll find some EPDs only cover A1 to A3. And so if you're looking at that EPD and then comparing it to one that has A, B, C, and D all shown, you can really only compare A1 to A3 between those different EPDs. And so, understanding what you want out of that assessment and what you are going to find in the EPDs you're looking at, you want to make sure that all of that aligns so that you're scoping this properly. So Mikhail sort of explained what an EPD is. From the climate point of view, when we're looking at sort of a carbon analysis of a building, we're looking at the global warming potential, or the GWP factor. That's one of 7 categories that are assessed in an EPD. So if you're thinking about climate change impacts, you're really only looking at one of 7 ways that these products are being assessed. And again, Mikhail mentioned that EPDs are third-party verified, and that there are program operators who do this for manufacturers. There are a bunch of them in North America and more in Europe and other places in the world. And if you're looking for these EPDs, in addition to places like the EC3 tool, you know, all of these providers usually have a database on their website so that you can search out the EPDs that they've done. So if you actually decide to wade in here and start reading EPDs, the first thing to look at when you see the document is whether it's an industry-wide EPD or a manufacturer-specific EPD. A lot of what exists now in North America are industry-wide EPDs, and so this is where the one you can see here is North American Softwood Lumber. So this is both the American Wood Council and the Canadian Wood Council collected data from mills all across North America and sort of presented an average for all softwood lumber everywhere in North America. And so that in some ways can be really useful because it can tell you a lot about wood as a whole product category, but it's not particularly useful at directing you towards which wood might be better than other wood. This is sort of giving one number for wood in general. Whereas the one on the right side, this is a CLT EPD by a particular manufacturer. And there are 3 different CLT manufacturers in North America who've produced EPDs. And so this is where you actually get to say, oh, you know, company A's CLT panel has a lower carbon footprint than company B's. And so you can actually start to think about procurement when you're looking at manufacturer-specific EPDs, whereas with the industry-wide ones, you're more comparing material categories to each other. So some key information when you're looking at an EPD. First of all, they have a 5-year validity period, so you want to check the date. So you'll notice the one I'm showing you is actually an out-of-date EPD. And because there was a flurry of these done in the early sort of like 2010s, it's not unusual to find a bunch of out-of-date ones, but if you see that the date has passed, you can try to look for the more recent version. And the verifier identification is usually front and center too, so that you know it's been done by a reputable party.
Chris, 2 minutes, please.
Okay. So within the EPD, there is a product description that tells you, where that product is used and where it goes. It gives you the scope of the EPD. So in this case, we're just looking at a cradle to gate EPD. So when I was showing you all those different categories, this EPD is only addressing A1 to A3. So I'm not going to be able to use this to compare the full life cycle of this CLT to the full life cycle of another one. I'm only going to be able to compare it at that cradle to gate phase. It's going to give you a declared unit. So in this case, it's a meter cubed of CLT. And it's going to tell you sort of what the system boundary is, where, what parts of the input and output are being looked at here. So here they're defining that extraction of raw materials through to the final cross-lamb product at the mill gate. And they're also going to tell you what's excluded. In this case, flows that are less than 1% of the total material flow and or less than 2% of the life cycle impacts. So, not absolutely everything in this process is being covered. This is what that looks like in a sort of diagram form, and you'll find this in most EPDs. So that little dotted line is the system boundary. So those are the flows that are being calculated in this EPD, and everything outside of that dotted line is not being counted. And then there will be a results table that looks something like this. And so if we're looking for the global warming potential, there it is. For 1 cubic meter of this company's CLT panel, it's 89.8 kilograms of CO2 emissions per cubic meter of CLT. Just to identify that term, kilograms of CO2e is the way to report the global warming potential of all greenhouse gases. So everything that's emitted in the manufacturing of that product is calculated, and then it's converted so that it shows up as CO2. So for example, if there's methane emitted, it's 1 kilogram of methane is worth 34 kilograms of CO2. So you would sort of, it's a way that when we're looking at CO2e, it's making it into a common denominator. So not all the emissions are carbon dioxide, but if we change them into carbon dioxide equivalents, then we're able to compare across products and across EPDs. And so I'm gonna probably skip through this very quickly, but if you're gonna start reading EPDs, the thing you need to know is that because it's giving you a figure for, in this case, a cubic meter of CLT, you can't really compare that cubic meter of CLT to, say, a cubic meter of concrete directly, because to replace CLT with concrete or vice versa, the amount of those materials that you need aren't going to be the same. So you then have to kind of take that functional unit from the EPD and do your material test and find an answer for the amount of material that you're going to need for your building. So here you can see I've sort of run through that for this CLT. But if I have 100 square meters of floor area and it's a 3.5-inch thick CLT, then I've converted that to 8.89 cubic meters. And now I can take the cubic meter result from the EPD and apply it to that amount of CLT.
Thanks, Chris. 1 minute, please.
Okay. And so just to wrap up, that's how you would do the calculations for every material that has emissions. If you want to look at materials that potentially are storing biogenic carbon, in some cases the EPD will actually give you that information. So this CLT EPD identifies how much carbon was taken in by these trees while they were growing. So for that cubic meter of CLT, there's 764 kilograms of carbon taken out of the atmosphere and stored in that tree. And the actual emissions that we looked at earlier would be subtracted from that so that we end up with a cradle to gate net. So in this case, the amount of carbon in the material minus the amount of emissions it took to make the material results in net storage of 678 kilograms of CO2e per cubic meter of CLT. If your EPD doesn't give that biogenic carbon storage, it's something you have to work out yourself. And from the EPD, you'll be able to see how much biogenic material was in the product. So we're here looking at cellulose insulation. There's 86% biogenic material. And you basically go through the math yourself to figure out how much of the mass is biogenic, how much of that is carbon, and then converting that to carbon dioxide.
Thank you, Chris.
Yeah, and this is how you do it for straw. So that's great. Hopefully that was fairly condensed, but a little how to read an EPD for you.
Thank you very much. Let's switch to Jesce.
All right. Can you see my screen?
Yes.
Here we go. Okay, I have to to go back to the beginning of the slideshow. Thank you, Chris. I would encourage everybody to check out the work that Chris is doing with biogenic carbon and some of his trainings to find out more. I'm personally really curious about how to quantify things like straw and timber. It's an area of research that is emerging and is extremely important, and he's a great leader in it. And thank you very much, Mikhail, for making EPDs a little bit cooler, even though you said they're not cool. I think that we learned some really important things from them, and in some ways, optimization is cool. I'm Jesce Walz. I am a designer at Perkins and Will. I'm based in our Seattle studio, and I'm here today to talk about EPDs, and in part because we signed on about a year ago as pilot partners with the EC3 tool and building transparency. Our firm values research and practice as two things that correspond closely together and inform one another, and we really saw the importance of having a database of EPDs that would be open source and easier to compare from one to the next. So I'm going to talk a bit about my experience with that. This slide is exploring the design process in relationship to LCA. And one thing to note is that really whatever part of LCA we are designing for, whether it is for end of life or for operational energy and use, we end up having the outcome of our design go into the building at this point right here that is somewhere between where a product leaves its gate and gets put on the truck to the building. Once materials are procured, a lot of the carbon story of the building has already been decided. So that's an interesting point. And a lot of the design process is spent preparing for this moment when construction documentation is complete and procurement has happened. And if we look heading out, if thought has gone into planning for the future phases of life, that may have happened already during pre-design through commissioning. I'm wanting to take a moment here to put EPDs and thinking about life cycle assessment and designing for life cycle in the context of a couple of other areas of research. One is materials health, and as has been stated, materials health isn't necessarily a part of LCA. They've really become two distinct efforts, and while some life cycle assessment considers toxicity to humans or ecotoxicity as a category, it's pretty rare because of the amount of variability and thousands of chemicals that might be in a material. So it may be better to look towards HPDs or material hazard assessments or third-party declarations for materials health. That said, the two processes have some things in common. There may be a system boundary or functional unit in EPDs and LCA. And in materials health, an HPD might reveal parts per million or declare what was disclosed and what wasn't. A primary difference is that EPDs are required to be verified, and some materials reporting standards are self-verified. But their big similarity is advocacy, and for those of you who are part of the materials health movement or still are, you may be familiar with the process of calling manufacturers and asking for information and working towards market transformation, and EPDs are really a part of that same story. Another area of study where EPDs overlap is operational energy reduction. And so here in the center, when we look at product declarations, a huge area of focus is global warming potential of the greenhouse gas emissions that a product is projected to emit throughout its lifetime. And we've already seen why global warming potential is a serious concern. So translating from life cycle assessment to perhaps a focus on GWP, and then looking at how does that relate to a building and its operational energy. And really, if we think about reducing operational energy, there are a lot of factors that come into play, like the energy source of the power plant, or establishing efficiency within processes and machinery that might be in the building. And that's actually similar to what might drive down embodied carbon on the manufacturer's end. What is the energy source for the plant? What are the efficiencies of extraction and manufacturing processes? And those two things meet up in the building. And here we see everything in blue is the embodied carbon, and the gray is the operational energy. And while they're two different systems, they come together to give us a picture of what could be called whole life carbon. And looking to make reductions and claims about being net zero or net positive or carbon neutral, we could start to think about these two things in conjunction. And the diagram on the top is exploring what if operational energy is balanced out, it's net zero, how long would it take for that building to pay off the emissions associated with its carbon impacts, embodied carbon impacts over time? And there are some examples like the Rocky Mountain Institute. I think that they optimized which systems needed to be in the building, made it net positive. It'll take 30 years for it to pay off its own embodied emissions. And the diagram that is lower is exploring more of what Chris was touching on, which is carbon storing materials. So if a building could become a carbon sink, then it can actually start to pay off its own energy relatively soon, and it becomes an energy producing resource earlier on in the process. So stepping back, what does the design process mean for EPDs, and how might we engage them in both a qualitative and quantitative manner? Here's some steps, and I have a couple of slides for each of these steps. The slides to follow are an expression of my own journey in learning how to use EPDs in the design process, and I've also cross-referenced them against tips from the Carbon Leadership Forum and World Green Building Council. So a primary thing is to establish intent.
Just
What?
minutes, please.
Okay, I guess I'm gonna have to run through those steps fast. What are the goals of the stakeholders, and how can we align around those to determine goals, scope, and drivers? What kinds of tools can support setting a budget and meeting that budget? Identifying a budget or a benchmark to meet and improve from is a key step in embodied carbon reduction. If we don't have something to measure against, then it's hard to know whether goals have been met. We hear a few standards and lead credits. An early step in the process is surveying the field. And here we can identify opportunities, constraints, resources, and availability of EPDs. A first step that I would take in this process is to go into the EC3 tool early on, even though it's used for procurement, set up a project and search for materials like cement mixes that I might want to procure from nearby, just to see whether there are manufacturers in the area with those things. And then following to collaborate and engage in early dialogue with builders, subs, spec writers, structural, and manufacturers. Within the design process, the EC3 tool and LCA introduce this point of conversation, and EPDs are a key entry point to that conversation. Through the data that they provide us with, we're able to assess and make comparisons and procure for the project. Innovation and optimization are also key here. It is harder to compare carbon storing materials with the EC3 tool, but we can do self-calculations, as Chris was saying, and also there can be different scopes of study, and comparing entire building structure systems to one another for primary material types, looking for redundancies and hotspots. And then iteration is also another key. Inventory and testing are an iterative process that doesn't happen just at one point, but occurs throughout the design process. And it happens at several scales. So again, it could be the structure. It also might be assemblies and determining which materials make the most sense for an assembly's performance and carbon impact, or it might be material specific, which is where we get into procurement. And getting into the EC3 tool, the tool does a lot of work to help allow us to enter into procurement with some confidence about the variability between products, so that we know that we can be making comparisons within one category. If we compare aluminum to aluminum, or one concrete mix with similar properties to another, we can really see what the carbon impact might be based on the work that the tools makers have done to clarify declarations. I think I'm going to breeze through these, but this is a note about specification, and that is a complex conversation, is how do we specify to ensure reductions? Lessons learned as we go. It's important to take note of rules of thumb and consider how those might feed into the next project. And these are things that I've already touched on. The key one being market transformation, that when we reduce per the rules that we've learned then and ask for more information, then we see the market start to shift. In order to shift the market, we have to have conversations, and here are some tips about speaking with manufacturers. A key tip out of these is to demonstrate the fact that this is becoming very competitive, and there are a lot of EPDs increasing in the online database for EC3. And also doing a little bit of homework doesn't hurt, because each manufacturer is going to be dealing with different upstream and downstream inputs, and they're going to have questions about how they can measure those. We can't answer all of those questions, and then we could connect the manufacturer to a program operator.
Thank you. Our time is running very short.
Okay. Thanks so much, everybody. This is stuff that Chris has already covered on. I just want to remind you all to engage with the CLF community and the importance of feeding back into the effort.
Thank you, Jessie. Thanks, Mikhail. Thanks, Chris. Wonderful presentations. Thank you to everyone who attended today. This will be available on the BSA website at no additional cost later in the week. You're going to need to, I'm going to need to go back 2 or 3 times to make sure I've absorbed it all. Please enter your name, email address, AI number if you want continuing ed. And please don't forget that next week, the Embodied Carbon 101 series continues with a session on structure. So please be sure to tune in again and look out for the recording of this session. Thank you again, and have a great day.
Thanks, everyone.
Thanks all.